Okay, so in this video we're going to be talking about how to simplify radicals, and we're also going to talk about pure imaginary numbers. To begin with, sometimes we're going to be taking the square root of a number where it doesn't work out perfectly and leave us with an integer solution. For example, square root of 81 gives us an integer solution because the square root of 81 is 9. But sometimes we might see something like the square root of 48 or some of these other examples that we have here where there's no number times itself that gives us the exact value of 48. Now there's a number of different ways that we could solve these types of problems. The method I'm going to show you is what I find to be the easiest to learn and the easiest to do for the most part. So let's look at the square root of 48. The method we're going to use is called using a factor tree. So you should be familiar with these. You might have done these in middle school. But for a factor tree, we try to find two numbers that multiply together to give us the previous number, and we work our way down until we end up with all prime numbers, giving us what we call the prime factorization. So for example, 48. There's a number of things that multiply together to give me 48, like 2 and 24, 4 and 12, 6 and 8, or just a few. We would not use 1 and 48 because obviously that doesn't help us get to our solution. So let's just use 6 and 8 for right now. Any of the factors would work. So again, if I use 2 and 24, it's not going to change my solution any. Let's just use 6 and 8. So 6 is not prime. So I want to find two numbers that multiply together to give me 6, like 2 and 3. 8's not prime either. That breaks down to be 2 times 4. By the way, one thing you might want to do is when you get to a prime number, like 2 and 3 are both prime. So I'm going to circle the prime numbers. We'll talk about why in a second. And 4, that's not prime. That breaks down to be 2 times 2. Now, my prime factorization are these numbers that I have circled. So that's one reason why I like to circle the prime numbers. So in that way I don't get confused and accidentally use any of these as part of my prime factorization. Okay. Now, what do we do with this? We're looking for the square root of 48. So remember, we're looking for what times itself would give me 48. So since it's a square root or a second root, for every 2 of the same number, I'm going to take 1 out. So in other words, take 1 out of the radical. So I have two 2's here. So I'm going to take that out of the radical. I have another pair of 2's here. So I'm going to take another 2 out of the radical. That leaves me with 3 that I can't do anything with, so that 3 remains under the radical. So in other words, my answer would be 4 times the square root of 3. Let's look at another one. Square root of 72. That breaks down into 9 times 8. 9 breaks down into 3 times 3. Those are both prime. 8 breaks down into 2 times 4. 2 is prime. And 4 breaks down into 2 and 2. Now note about prime numbers. Prime numbers are numbers that can only be, the only numbers that divide into it are 1 in itself. So here's a list of prime numbers like 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. We won't be dealing with numbers probably larger than 7, but those are a list of some prime numbers there. But going back to the square root of 72, so we're left with our prime factorization here. So again, for every 2 of the same number, I get to take 1 out. So I get to take out a 2. And I have a pair of 3's here, so I get to take out a 3. I'm left with the square root of 2. So 2 times 3 is 6. My answer is 6 square root of 2. Why don't you guys try this last one on your own? So why don't you pause the video and hit play when you're ready to check your answer. Okay, so let's see what you did here. So square root of 600. One thing you could say is it's 6 times 100. Well, 6 breaks down into 2 and 3, and those are both prime. 100 breaks down into 10 times 10, and 10 breaks down into 2 times 5. Those are both prime. Again, for every 2 of the same number, we get to take 1 out. So there's a pair of 2's. There's a pair of 5's. We're left with a 2 and a 3 this time, so that's what stays in the radical. So when I simplify this, 2 times 5 is 10. 2 times 3 is 6. So my answer is 10 square root of 6. Now that's going to be helpful knowing how to do that with today's lesson, because this, what I just showed you, is not explained in the book. They expect you to already know how to do that. So if you need to for future reference, you'll want to refer back to this video. But now, what happens when we have the square root of a negative number? Now, this is saying when k is less than 0, so when we have the square root of a negative number, there's going to be two solutions to x squared equals whatever that negative number is. So if I have x squared equals negative 81, there's going to be two solutions: a positive square root of that number and a negative square root of that number. Now, we can't take the square root of a negative number. If on your calculator, if you took the square root of negative 81, it's going to give you an error. It will say something like domain error, or no solution, or it'll give you some kind of weird message. It's because there is no number times itself that gives me negative 81. I should say there's no integer times itself that would give me negative 81. There is a non-real solution that we could talk about, and that's this letter I. And this is real important here. Way back when they came up with this problem, where maybe they were solving a problem with a parabola, where it was a parabola, but when they used a quadratic formula, they got the square root of a negative number, and they realized, well, we got to have some way around this to be able to simplify this further. And so someone came up with this idea of the square root of a negative 1, using I to represent that value. So it's kind of like, we're familiar with pi. We see that as a symbol, and we know that that's the same as 3.14159, and it keeps going on and on and on. You need to recognize now that this letter I is the same as the square root of negative 1. And speaking of that too, we have a value for I squared. Now think about this for a second. If I take the square root of 2 and square it, that's going to give us 2 as our answer. If I take the square root of 3 and square it, that's going to give me 3 as my answer. Now if I have the square root of negative 1 and square it, well, the square root of negative 1 is the same as I squared. Oops. So if I have the square root of negative 1 squared, that's going to be the same as negative 1. So I squared is the same as negative 1. So these are the two things that you need to remember. That I is the same as the square root of negative 1, and I squared then is the value of negative 1. Okay, now it's very important. I is not negative 1. I is the square root of negative 1. I squared is where we have negative 1. Now that's going to be coming into what we talk about in the next video. But for right now, we're going to use this first part. Now, this paragraph here ties into this first box. Recall from earlier in the chapter that the square root of x squared is the same as the absolute value of x, meaning that we're going to end up with two solutions, a positive and negative. So when we have x squared equals negative 1, one solution is going to be a positive square root of negative 1, or just I. The other solution is going to be a negative square root of negative 1, or the opposite square root of negative 1, which we call negative I. So there's going to be two solutions when we're solving these equations, a positive and negative solution. That's what they're getting at in this box, but tying it into imaginary numbers, we'll have possibly an I or a negative I. Now, if we have multiples of I, like 7i, or negative 2i, or 12i, or 3i, we call these pure imaginary numbers. Now, what this box is saying is the square root of a negative number theorem is that if we have a number less than 0, so let's say negative 2, the square root of negative 2 is going to be I times the square root of the opposite of negative 2, or positive 2. They're kind of confusing, so let's look at some more concrete examples. Let's go back up to what we were referring to earlier. Instead of the square root of 48, what if we had the square root of negative 48? Well, what this is saying is that this is equivalent to, anytime we have the square root of a negative number, we take out an I, and it's what's going into the radical is the opposite of what we had originally, or a positive 48. And now we know when we simplify when we simplify square root of 48, we got 4 square root of 3. So this means that our answer would be 4i times square root of 3. or if we had the square root of a negative 72. To make this a positive square root, I would take out an I and have this be now this positive square root of 72. And square root of 72 we found early to be 6 square root of 2, so it's going to be 6I square root of 2. Or like the one that you guys did on your own, what if it now was negative 600? Well, I would take out an I, so this would be square root of 600 now, I times the square root of 600. And square root of 600 you found to be 10 times the square root of 6. This is going to be 10I times the square root of 6. So when we have the square root of a negative number, the only difference here is that we take out an I and then we simplify it. But remember, if we have a situation like this, we're going to have two solutions. Okay, so let's go ahead and solve this problem. Here we have 2x squared minus 5 equals negative 55. Just like earlier in the chapter, we want to get the x squared by itself. So what I'm going to do is I'm going to add 5 to both sides. So I get 2x squared equals negative 50. Don't do anything with the x squared yet. I always save that for last. Or next, I'm going to divide by 2. So I have x squared equals negative 25. Now I take the square root of both sides. But remember, this means that I'm going to have square root of x squared means I'm going to have two solutions, a positive and a negative. So that means I'm going to have x equals a positive and a negative square root of negative 25. But now let's simplify that. I'm going to first start out by taking out an I, making that a positive square root of 25. Square root of 25 is 5, so that means my answer is a positive negative 5I is how we write that. Once you guys try the next one on your own, negative 3x squared minus 18 equals 30. I want you guys pause the video and hit play when you're ready to check your answer. Okay, so we start out by adding 18 to both sides. Giving me negative 3x squared equals 48. Next, I'm going to divide both sides by negative 3. Giving me x squared equals negative 16. Now when I go to solve this and I take the square root of both sides, I get x equals a positive and a negative square root of negative 16. But remember, I want to take out an I to make it a positive square root of 16. Square root of 16, that simplifies nicely to be 4. So my answer for x is that it's a positive and a negative 4I. Okay, let's look at another one together. It says solve 2x squared plus 50 equals negative 50. So I'm going to start out by subtracting 50 from both sides. Negative 50, oops. Negative 50 minus 50 is not 0. Negative 50 minus 50 is negative 100. Again, don't take the square root of both sides. You'll get the answer wrong. We have to divide both sides by 2, giving me x squared equals negative 50 again. But now when I take the square root of both sides, let me do this over here. So you end up getting x equals the square root of, or positive negative square root of negative 50. So this would be positive negative I times the square root of 50. But 50, there's no number times itself that gives me exactly 50, so I need to break this down. So 50 breaks down into 5 times 10. 10 breaks down into 5 times 2. So again, for every 2 of the same number, I get to take one out. So that means my answer is x equals a positive and negative 5I times the square root of 2. Let's look at another one. So we're going to subtract 80 from both sides. Gives me x squared equals negative 180. Take the square root of both. There's nothing to divide by, so next I'm just going to take the square root of both sides, giving me x equals a positive and a negative. I can just go ahead and simplify this now to be I times the square root of 180. why don't you guys take and simplify the square root of 180 and then tie this all together and see what your solution is. So pause the video from here and hit play when you're ready to check your answer. Okay, let's see how you did. So 180 breaks down to be, let's say, 10 and 18. Again, you could have started out this differently. You could have said 2 and 90 if you wanted to. You'd still end up with the same solution. But 10 breaks down into 2 and 5. 18 breaks down into 3 and 6. These, by the way, are all prime. 6 breaks down into 2 and 3. So for every 2 of the same number, I'm going to take one out. So I have a pair of 2's here. So that's going to be, write this down here, so it'll be 2 times, and I have a pair of 3's. So that just leaves me with the 5 that's going to be left under the radical. So my answer, putting this all together now, would be x equals a positive and negative. 2 times 3 is 6, so 6i times the square root of 5. And that would be my final solution. So the things to remember from this lesson is that when we have a solution, when we have x squared involved, remember, we're going to have 2 solutions, a positive and a negative. And if we ever have the square root of a negative number, we take out an I. In the next video, we're going to use that fact that I squared equals -1 to deal with some different operations with an imaginary number. So with that, good luck on your assignment.